Watt 949, Princeton, New Jersey. Einstein's 70th birthday. His best friend, Kurt Gödel, possibly the greatest logician in human history, has prepared a gift for him. It's not a cake, it's not wine, it's a manuscript. 6 pages of equations, written entirely in Einstein's own language, the field equations of general relativity, a mathematically airtight proof. And what it proves is one sentence long. According to your own theory, time does not exist. Not time is strange, not time is relative. Time does not exist. Einstein read it. He sat with it. He wrote a response. Careful, polite, the kind of language a man uses when he's trying very hard not to admit what just happened. He raised objections. He moved the conversation sideways. He never refuted it. In his autobiographical notes, written around the same time, he left behind a sentence that historians have been arguing about ever since. He wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. Most people read that and assume he was being poetic. He wasn't. He was telling us what his best friend had just proved to him, that the universe you live in, this one, the one you're sitting in right now, watching this, has no past, has no future, has no flow, that time doesn't pass, that you, at this exact moment, are not actually doing anything. You already exist at every moment of your life all at once. And what feels like the present, this breath, this thought, this second, is just one frozen slice of something that was never moving to begin with. That's the gift Gödel handed Einstein for his 70th birthday. The man who invented general relativity couldn't find a way out. 75 years later, neither can we. Because every time someone sets out to prove Gödel wrong, they run into the same wall. Before they can argue about whether time flows, they have to answer a much older question first. Is time a real thing that actually exists out there? Or is it something we invented, a story we tell ourselves? And to answer that, you have to go back to the beginning. Back to the first man who nailed time down into the laws of physics. That man was Isaac Newton. In 1687, in the Principia, he wrote down the definition of time the way a prophet hands down scripture. Absolute true time, he said, flows on its own, uniformly, eternally, with no regard for anything outside it. It is a river. It runs from past to future. It treats kings and beggars alike, treats the earth and the most distant star alike. Stand still, and it flows. Run, and it flows the same. 24 hours a day, down to the second, the whole universe sharing one single now. The picture fit our intuition perfectly, so perfectly that for the next 200 years, almost no one questioned it. It became the bedrock of physics and one of the deepest beliefs an ordinary person holds about the world. Before time, all are equal. That sentence is false. And the thing that proved it false was not philosophy, not argument, it was light. Hold one fact in your mind. You don't need to understand it. You only need to accept it. The speed of light never changes. 4 plain words. The damage they do is total. Picture a race on the ground. A beam of light shoots out at 300,000 kilometers per second. You climb into a ship and chase it, accelerating until you are almost at the speed of light yourself. By Newton, by common sense, by everything you've understood since the day you opened your eyes. That beam should slow down relative to you. It should crawl ahead, barely pulling away. The universe gives a different answer. No. That beam leaves you at 300,000 kilometers per second. Exactly. It does not slow by the smallest fraction. No matter how fast you fly, no matter which direction, the speed you measure for that light is always the same number. It will not bend. This is not a guess. In 1887, an experiment of extraordinary precision measured it again and again. No matter which direction the Earth moved, the speed of light did not budge. That result nailed those words, "The speed of light never changes," to the wall of physics. Why the speed of light holds constant, no one to this day can say. But hold constant it does. And this fact has nowhere to live. It cannot coexist with Newton's universe. Between the two of them, one has to be sacrificed. The one sacrificed was time. Why time? Let me show you the cleanest example there is. Imagine the simplest possible clock. 2 mirrors, one above the other, and a single point of light bouncing straight up and down between them. Every round trip, 1 tick. That's a clock. It keeps time using nothing but the speed of light, and the speed of light never changes. Now put that clock on a fast-moving ship. The person inside the ship looks at it. The light still bounces straight up and down, tick after tick. Everything normal. But I'm on the ground watching the same clock, and because the ship is moving forward, that point of light, to my eyes, no longer travels in a straight line. It bounces up and down while drifting forward with the ship. So from where I stand, it travels a diagonal, a longer path. Here is the key. The speed of light does not change. The light covers a longer path in my eyes, but it cannot move any faster, so it can only take more time to finish one round trip, which means, to me, that clock ticks slower. The clock isn't broken. The light is the same light. What slowed down is time itself. For the person on the ship, everything is normal. For me on the ground, his time, truly, measurably, has slowed. You think this is science fiction. It is sitting in your hand. The navigation on your phone depends on GPS satellites overhead. They move fast, and the atomic clocks they carry no longer tick in step with the clocks on the ground. Engineers have to correct that gap every single day. Stop for 1 day, and your position drifts by more than 10 kilometers. 2 days, and the screen says you're home while you stand in another city. Every time your navigation quietly leads you home, it is repeating the same verdict. Newton was wrong. That river, running at the same rate for everyone, it does not exist. Your time belongs to you alone. Speed is not the only thing that slows time. Gravity does it too. Any object with mass drags on the time around it. The closer you are, the slower it runs. The sharpest proof of this is a pair of twins, Scott and Mark Kelly, both NASA astronauts, born from the same womb 6 minutes apart. The same age their whole lives, down to the second. In 2015, Scott went up to the International Space Station and stayed 340 days. Mark stayed on the ground. When Scott set foot on Earth again, he was younger than his twin brother. This is not a figure of speech. NASA has the data. From that day on, the ages of these two twins can never line up again. A man who has been to space and his mirror image left on the ground now live in two slightly separated streams of time. Now walk with me to the deepest part of this. If time bends with speed, bends with gravity, runs differently for every single person, then one question suddenly loses its answer. Right now, across the whole universe, what is happening? The question sounds beyond obvious. We all assume there is a now, a single instant the whole universe shares. In the second I breathe here, someone sleeps on the other side of the Earth. A rock lies still on Mars. A star burns in Andromeda. All of it happening in the same now. Einstein said that now is an illusion. One picture is enough. No equations. You only have to see it. A train, moving fast. In the exact center of a car hangs a lamp. The lamp lights up and sends out two beams at once, one toward the front of the car, one toward the back. Inside the car, a person stands directly under the lamp. Front and back are the same distance away. The light travels at the same speed both ways. So the two beams reach the two ends at the same moment, simultaneously. On the platform, another person watches the train pass. In their eyes, everything changes. The train is moving forward. The back of the car is rushing toward its beam. The front is racing away from its own. The speed of light does not change, so the light reaches the back first, the front second. What the person on the platform sees is this. The light hits the back of the car first, the front of the car after. So which is it? Simultaneous, or one before the other? Person on the train says simultaneous. The person on the platform says one came first. Who is wrong? No one is wrong. What both of them see is real. In this universe, the question, did two things happen at the same time, has no single answer. It depends on who you are, where you are, and how fast you are moving. Think about what that means. If even at the same time changes from one person to the next, then that now we all believed we each carried a copy of Nell the poets wrote about, one moment shared across all the world. It never existed. Your now and my now are not the same thing. Your present may be precisely some other observer's past, or their future. In this universe, there is no single shared now. There never was. But wait, if the now does not exist, if my now can be someone else's past, then has that past never disappeared? Is it, at this very moment, still there? Go one step further. If someone else's now can be my future, then is my future already there too? Already existing, just waiting for me to arrive? If the past never vanished, and the future already exists, then is time flowing at all? This question carries us to a place deeper and colder than time slows down. A place that unsettled Einstein himself. There, you are not living through your life. Your life, from the first second of your birth to the last second of your death, every moment of it is already written, laid out, quietly, waiting, and you have only been pressed play. And that play button raises a new problem. If you are being played, then the past has not vanished, the future already exists, and time may not be flowing at all. You might assume this is just one of those unsettling thoughts that surfaces late at night and means nothing. It isn't. This idea has a name, A group of the most rigorous physicists on the planet followed Einstein's equations, pushed it step by step all the way to the end, and found they had nowhere left to run. They could only admit it was true. They call it the block universe. And what it says is, colder than anything you just imagined. We have always believed time is a river. It flows in from the past, rushes through this moment, and races toward the future. We stand on the point called now, watching the future turn into the present, then fall behind us into the past, and vanish. The block universe says, there is no river. Time is not a flowing river. It is a frozen dimension. Space has up and down, left and right, forward and back. Time is the fourth direction, and along that direction, the past, the present, and the future exist all at once, like different floors of a single building standing together. No first, no last, all of them equally real. The entire universe, from the first star igniting to the last star going dark, is one solid, frozen, four-dimensional thing. The Big Bang is not long ago. It is right there, at one end of the time direction, existing still. The end of the universe is not in the distant future. It is at the other end, existing already. In the block universe, the word happen has no meaning. Nothing is happening. Everything simply is. I know what you want to say. You want to slam the table. Nonsense. I can feel time flowing. I remember yesterday. I don't know tomorrow. This moment is happening right now. How can that be fake? This is the most important question of all. If it can't be answered, everything I've said is empty. So picture a reel of film, an old movie, the kind run on film. That reel is made of thousands of still images, each one fixed, motionless, shot, and developed long ago. The first frame and the last frame lie there on the reel right now, complete, equal. The whole film, beginning to end, exists all at once. The film itself has no time, no flow. It is just a long strip of still pictures. So where does the movie come from? The feeling of characters running, falling in love, growing old, time passing, where does that come from? It comes from the projection. When the projector's light sweeps across the strip, one frame every 24th of a second, the still images come alive, the characters move, the story flows, time seems to surge forward. But look closely. What makes you feel time is flowing was never the film itself. Every frame on that strip, from the first to the last, is still, fixed, finished, already there. What moves is only the point being lit, which single frame is glowing right now. Now replace that projector with you. The entire reel is your life. Every frame already shot, already complete, all existing at once. Your consciousness is that point of light. It lights up one frame at a time, and the frame it happens to be lighting you call now, so you feel time flow. You feel yesterday behind you, tomorrow ahead, this moment happening now, but nothing is actually moving. The film was always still. All that changes is which frame is lit. The universe is not flowing. It is you, the light, moving across a life that was already completely there. Now turn that light toward yourself. If the whole reel is already shot, then every decision you'll make tomorrow is already on the strip, right now. You think tomorrow morning you will decide between coffee and tea, but that frame is already there, already shot, already developed. The moment of your decision, along with the feeling that you are freely choosing it, is part of an image that already exists. You are not reading a story that is unfolding. You are reading a book already printed and bound. The ink dried long ago. You are only turning page by page to the page you happen to be on. Your birth, your first love. This second, right now, watching this video, your aging, your death, they are not going to happen. They have always been there. They will always be there. You are not alive. You just happen to be passing through this one frame. You are not a candle burning down, growing shorter. You are a candle already burned out, and yet standing there, whole, forever. The whole candle, beginning to end, all at once. By now, this is cold enough to make it hard to breathe. But stay with me one more moment, because hidden inside this cold strip of film is something warm enough to bring you to tears. If every moment of your life exists forever, then every person you have lost has never truly left. Your grandmother, the one who cooked for you when you were small, the one who is gone now. In the block universe, she has not vanished. Every day she lived, every time she smiled, the road she walked holding your hand, all of it still exists right now, somewhere along that direction of time, complete and forever. That afternoon you spent with her, it is not in the past. It is forever happening. We think of death as an erasing, a person deleted completely from existence. But if the block universe is real, then nothing is ever deleted. Every moment you loved, every face you lost, the universe keeps it, whole, forever, right there. But there is a crack in all of this. If everything is frozen, if the past and the future exist just as truly, just as certainly, then answer me one question. Why? Why do we remember only the past and never the future? If that book is already printed, if the pages ahead are as real as the pages behind, why can you read the ones behind you, but never the ones in front? Why does time run in only one direction? A film can run backward. In space, you can move left or right, but time, you have never once seen anyone walk from the future back into the past. A shattered cup does not reassemble. Spilled water does not return to the glass. The old do not grow young. If the past and the future are equally real, what gives time its direction? Physics has a beautiful answer to this, an answer that lets you breathe again. It will tell you exactly why you feel time flowing. And compared to everything you've just heard, it sounds reassuringly, almost comfortingly, safe. The answer is entropy. Picture a world where time runs backward. A shattered plate leaps off the floor, its pieces flying back together into a whole dish that settles onto the table. Smoke pours back down into a burning cigarette. An old man walks backward through the years, his hair darkening, his back straightening, until he steps back into the crib he was born in. Here's the strange part. Nothing in that backward world breaks a single law of physics. Run it frame by frame, and every collision, every motion is completely legal. The equations do not forbid any of it, and yet you have never seen it happen. Not once. In our universe, it only ever goes one way. Plates shatter, smoke disperses, people grow old. So why? If the laws of physics would allow the backward version, why does it never happen? Because of probability. That's all entropy really is. Take a box, divided by a wall. Every air molecule is packed into the left half. The right half is empty. Pull the wall out and the molecules instantly spread to fill the whole box. You will never see the reverse, those molecules spontaneously crowding back into the left half on their own. Not because it's forbidden. In theory, it could happen. But there is exactly one arrangement where they're all packed neatly on the left, and an almost infinite number of arrangements where they're spread out everywhere. So the system always moves toward the spread out version, toward mess. That is the arrow of time, not a law, just odds. Order has one form, disorder has countless forms. The universe is always sliding toward disorder, and the direction of that slide is what we call the future. Now put this together with the block universe, and something clicks into place. The block is still frozen. Every frame of your life still exists at once. That hasn't changed, but the frames are stacked in a specific order. Low entropy at one end, high entropy at the other. One end of your life is more ordered, the other is more disordered. That ordering is fixed, baked into the block. So why do you remember one end and not the other? Because of how memory works. A memory is a record, a physical trace left in your brain, in a photograph, in the wear on a doorstep. And here's the key. Leaving a trace is itself an act of increasing entropy. You can only record something by nudging the universe one step further into disorder. That means records can only accumulate in one direction. The direction entropy increases. The low entropy end of your life leaves traces that pile up toward the high entropy end. So standing at any frame, you can look back toward the ordered end and see a trail of records, memories. Look the other way, toward the disordered end, and there are no records yet. Nothing has been written there. That's all remembering the past is. The past is just the direction with more order behind it, and therefore the direction full of traces you can read. You don't move through time. You sit in the block, and on one side of you the records pile up. You call that side the past, and the act of reading those records you call memory. So everything fits. Time doesn't flow, but the feeling that it does has a clean, physical, reasonable source. The universe is frozen. The frames are ordered by entropy. Your memories point down the entropy slope, and that one-way trail of records is the entire reason you feel yourself moving from past to future. It all adds up. You can relax. Entropy always increases. Everything slides toward disorder. Life runs the other way, not by breaking the rule, but by reversing it locally, for a while. In 1943, the physicist Erwin Schrödinger put this in one line. Life, he said, feeds on negative entropy. A living thing stays alive by pulling order in from outside itself. That is literally what your body does. Every cell holds a precise internal order while everything around it decays. To hold that order, it needs fuel. So you eat, you breathe, you take in low entropy structure from the world, and use it to repair what disorder keeps tearing down, dumping the resulting mess back into your surroundings. You are a pocket of order running upstream. The structure holds for around 80 years. Then it loses, the way all of it loses, and the atoms that briefly formed a person return to the disorder they came from. And this is the part worth holding on to. Order like this can only exist in the middle of decay. There is no version of the universe where things last forever, and a sunrise still means something. A moment matters precisely because entropy will erase it and never bring it back. The same law that guarantees the end is the only reason any of it was ever beautiful. So the puzzle appears to close. Time does not flow. The flow is an illusion resting on entropy. Memory points one way because records pile up one way, and the brief, structured anomaly of being alive is what climbing against that slope feels like from the inside. It is clean, it is complete. It explains almost everything, but it has one flaw. Entropy is a law about crowds, trillions of particles averaging out. It says nothing about a single particle, and it says nothing about what happens the moment you choose to look at one. In 1978, John Wheeler designed a way to look at exactly that. What he found did not slow the arrow of time, or bend it, or speed it up. It turned it around. To understand Wheeler's experiment, you need the one it grew out of, the double-slit experiment. It is the strangest result in all of physics. Fire a beam of light at a barrier with two narrow slits. On the wall behind, you get a striped pattern. Bright bands, dark bands, alternating. That's interference. It's what waves do. Two waves overlap, some spots reinforce, some cancel. So light is a wave, settled. Now slow it down. Instead of a beam, send the light one particle at a time, one photon. It goes through, hits the wall, leaves a single dot, send another. Another dot you'd expect, after thousands, two simple bands behind the two slits. You don't. You get the stripes again. The interference pattern builds up dot by dot, even though the photons went through one at a time with no other photon to interfere with. Each photon interfered with itself, which only works if a single photon went through both slits at once. One particle, two slits, both at the same time. So you do the obvious thing. You put a detector at the slits to catch which one each photon actually goes through. The moment you switch that detector on, the stripes vanish. You get two plain bands, two slits, two piles, the way particles should behave. Each photon now goes through exactly one slit. Stop and hold this. When no one checks which slit, the photon takes both. When someone checks, it takes one. The only thing that changed was whether the path was observed. Watching it changed what it did. Here's where Wheeler stepped in. He asked a question that sounds innocent and isn't. When does the photon decide? Maybe, he said, the photon senses the detector at the slits. It arrives, finds it's being watched, and chooses to behave as a particle, one slit, or finds it's not being watched and behaves as a wave, both slits. Strange, but at least the order makes sense. The photon reaches the slits, checks the situation, then decides. So Wheeler proposed a trick. Don't decide whether to watch until after the photon has already passed the slits. Leave the slit detectors off. Let the photon go through. It's now past the slits, traveling toward the back wall. According to the logic we just used, the decision is already made. It went through as a wave, both slits. The moment of choosing is behind it. And then, after it's through, in the last instant before it lands, you choose. You switch on a different detector, further down, that reveals which single path it took. By every intuition you have, this should be impossible. The photon already passed the slits. It already chose. Your decision came too late. When the experiment is actually run, and it has been, in real laboratories many times, the photon's behavior always matches your choice. Switch the late detector on, and you find it went through one slit like a particle. Leave it off, and the interference returns. It went through both like a wave. Your choice, made after the photon passed, determines how it passed. The photon traveled through the slits. Then you decided what it had done while traveling through them, and it had already done it that way. Let that sit. The event happened first. The choice that fixed it happened second. The cause came after the effect. This is not a measurement error. It is not the photon being clever. It has been confirmed again and again across 40 years with light, with larger particles, with ever tighter controls. The result never changes. In the quantum world, the past is not fixed until something forces it to be. And what forces it is the act of looking. Now Wheeler did one more thing. He took this experiment and made it the size of the universe. In the lab, the photon travels a few meters, and your choice trails it by a few billionths of a second. Wheeler asked, what if the distances were astronomical? What if the delay were not nanoseconds, but billions of years? Out in space, this setup already exists. It's called a gravitational lens. A quasar, a blindingly bright young galaxy, sits billions of light years away. Between it and Earth lies a massive galaxy, close to our line of sight. That galaxy's gravity bends the light passing it, the way a lens bends light. So a photon leaving the quasar has two routes to us, around the left side of the intervening galaxy, or around the right. Two paths, the same situation as the two slits, except these slits are an entire galaxy apart, and the journey between them takes billions of years. So here tonight, you point a telescope at that quasar, and you choose how to look. Set it up one way, and you measure which side the photon came around. Left or right, it behaves like a particle. It took one path. Set it up the other way, and you let the two paths interfere, and the photon behaves like a wave that came around both sides of the galaxy at once. The photon left the quasar billions of years ago, before the Earth existed, before the Sun existed. The choice of which way it traveled, one side or both, appears to be settled by an astronomer making a decision tonight. A decision made now, reaching back across the entire age of the universe, to set what a particle did before our planet was even born. The delay is no longer a billionth of a second. It is 10 billion years, and it changes nothing. The result is the same. Your choice now fixes the past, a past older than everything you have ever known. The frozen block was supposed to be finished, already shot, already printed, but the ink on a page written 10 billion years ago is still wet, and it stays wet, waiting until someone looks. Wheeler spent the rest of his life on what this means. He died in 2008, at 96, still turning it over. And the conclusion he reached is the most unsettling idea in this entire video. If the act of looking is what fixes a photon's past, then reality is not something that simply sits there, finished, waiting for us to notice it. Reality is not complete until it is observed. Wheeler called it the participatory universe. We have always pictured ourselves as latecomers. The universe ran for 13 billion years. Stars, galaxies, an ocean, a planet, and then, at the very end, we showed up to watch. Spectators arriving after the show began. Wheeler's experiment says we have it backward. The watching is not separate from the universe. The watching is part of how the universe becomes real. Every observation reaches back and helps settle what was. In his words, the universe gave rise to observers, and observers, in turn, give reality to the universe. It made us so that we could turn around and make it. Now hold both halves of this video in your head at the same time, because they should not fit together. The block universe told you everything is already written. Your birth, your death, every moment in between. Fixed, frozen, finished. The page is printed. The delayed choice experiment told you the page is not finished, that a choice made now reaches back and decides what the past already was. The ink is still wet. Both are built on the same physics. Both have been confirmed, and they cannot both be simply true unless the thing we call the past is not a place that is over and done, but something still being settled, still being written by every act of observation, including the one you are performing right now. A book that is already complete and still being written at the same time. So who is writing it? That question does not have an answer yet. Maybe it never will. But step back to where we began. An old man in 1949 handing his best friend a birthday gift, a proof written in Einstein's own equations. That time does not exist. Einstein read it and could not refute it. 75 years later, we still can't. We have only gone deeper. We found that now is not shared, that your life already exists, all at once, frozen in a four-dimensional block. And then we found that the block is not as finished as it looked, that the past stays open, unwritten in places, until something looks and closes it. Here is what all of it leaves you with. The flow of time you feel, the sense that this moment is happening, that it is sliding from a fixed past toward an open future, is the one part of all this that physics cannot find. The equations don't contain it. The block doesn't need it. The single particle doesn't obey it. It exists in exactly one place, inside you, in the act of being aware, frame by frame, of a universe that is not actually moving. You are not standing in the river of time being carried along. There is no river. There never was. There is only a vast, still structure. Every moment of your life held in it permanently, and a small light moving across it, lighting up one frame, calling it now and moving on. That light is the only thing that was ever moving, and it is you.